Students, welcome to my channel Content Hub. Today I am going to explain about the disadvantage of the linear probing as well as quadratic probing, and also I will explain how to resolve, so please watch the complete video. So first one is that primary clustering. This is the problem of the linear probing. So before going to all this problem, first we have to understand what is the primary clustering and also what is the clustering. Clustering is nothing but a group of element. So you are if you see that the hash table, there is a group of element. So all this is forming a one group. Similar like that, suppose there is some element is here, some element is here, and in between there is a space, so this is another group. So like that group is forming, this is nothing but a one clustering. Now the situations come that if saying what is the primary clustering. So here is saying that if two key element, if you are going to insert if I am going to insert the element in the hash table, that in that time if two element get the same starting index. So same starting index. Starting index, it means that suppose I am going to store here I'm going to insert the 50 and 60. So if you calculate the index using the given hash function, you will get the same address, same starting address 0 0, right? So what it is saying that they both following the same path unnecessary in the linear manner. Why? So in linear probing I have already explained. Those who haven't watched that video, please watch, then only you can understand this video. So in 50 and 60, you can see here in the linear probing, always what it will do, if collision occur, they will check immediate next one, is it free? If it is that one also not free, they will check that immediate next index. If it is that also not free, they will check the immediate next index. Like that it's following. So similar like that here, if I'm going to insert 50 and if I calculate the index of the 50, I will get 0. Then what will do, check that is 0th is free. If it is 0 free, then it will going to store at 0, means there is no collision. If 0 is not free, then it will check that immediate next index, and that to 1. Is 1 is free? If it is 1 is free, then you insert. If it is not free, then check the next element, next index. Like process you follow for the all these element. So similar like that, if 60 come, for 60 its index is also starting index is 0. Then check that each first index 0th index is free. If it is not free, then check that each first index is free. No, that's also not free. Each second index is free. That's also not free. Third index is free. That also not free. Fourth index is free. Not free. Fifth index is free. Yes, free. Then it's 2. So if you observe here, while inserting the 50 and while inserting the 60, both is following the same path. Right, both is following the same path, and because of that reason the worst case time complexity as well as the average case time complexity is order of n, and this problem is called primary clustering problem. This problem is called primary clustering problem. Now one more scenario I will show you that in the primary clustering is what. Suppose I have this cluster. Suppose this is the one cluster in my hash table already. So suppose this is the cluster, right? And if 80 will come. Suppose if I am going to store an element and their index you are getting the 0. Suppose you are getting the and one more thing, I'll just give that some value here. So this is suppose 2 and 18. I simply am putting that. So this is for your understanding. So this is one cluster. This is one cluster. So similar here 2 and this is 16 and 18, whatever you say that. So this is one cluster. So this is for your understanding. I'm just making that. This is 2 and 18 here. And here also 2 and 18. So this is another cluster. So this is another cluster and this is another cluster, right? So what happened here, suppose either you are going to store 80 and either you store 81, either you store 82 or 83 as well as 84, right? I'll also give that 84. So either you are going to store 80, 81, 82, 83 and 84. So how many elements? 5 elements. All these 5 elements will get the chance to insert at where? 4th index. Because your hash function is what? Key modulus table size. Right? If you are going to use linear probing To insert 80, if 80 will come, then what will you check? You will check that if you calculate the index of the 80 using the hash function, you will get the 0 index. So either 0 will come. What will you check that? 0th free, not free. First free, not free. Second free, not free. Third free, not free. Fourth is free, yes. Fourth is free. So 80 is going to store at where? Fourth place. Right? Suppose 80 I am not going to store, 80 not came. Suppose 81 came. Let's 81 came. 81 came. 81 index is what? 1. It will check that first index is free. No, not free. Second index is free. Not free. Third index is free. Not free. Fourth index is free. Yes, fourth is free. So either 80 is coming or either 81 is coming. Both is getting chance to insert at where? 4. Right? Because of this cluster. Because of this cluster. Now 82 came. Suppose I am not storing 80 also, 81 also. Now I am going to store 82. So 82's index is 2. So go and check the second index. Is it free? No, not free. Third index is free? Not free. Fourth is free? Yes. 82 is also getting chance? 4. Right? So suppose I am not storing 80, 81, 82 and 83 I am going to store. So 83's index is 3. So check that third is free? No, not free. Fourth is free? Yes, fourth is free. Right? So suppose I am not storing 80, 81, 82, 83. Now I am going to store 84. Then what will I do? 84 index you will get 4. Check that fourth index is free? Yes, free. So if you observe here, you will get that either 80 will come, either 81 will come and 82 come, 83 come and 84 come. All 5 will get chance where? At 4 index. And why you are getting that fourth index? Because of this clustering and as well as the linear probing situation. In linear they are saying that always store immediate next index, and because of that reason the primary clustering problem arises in the linear probing. So here you can observe here the single slot is having highest probability, and the probability is what? 5 by 10, means 5 element will come. All these 5 will get the chance to insert at fourth index. Similar like that, if I am saying that insert some element like 89, if you are going to insert the 89, sorry, not 89, 87, if it is 87 will come. So that 87 is also going to get chance to store at 9. Right? If I say that 88 also get the chance to store at where? At 9, or 89 also get chance to store at 9th index. So here also this slot is having highest priority, and that priority is what? Probability, and probability is what? 3 by 10. 3 by 10. So this is the probability. So what happened in the linear probing, there are some slot, because of the clustering they are getting more probability, they are getting more probability. Right? For similar like here the fifth, if I say that fifth index, fifth slot, what about this? For this one there is a probability is 1 by 10 only. Here you get that if it is you are going to store the 85, simply go and check that is fifth index is free. Yes, free, then you simply store that. So there is a, here there is a some slot is getting high probability, and that problem is called primary clustering, and that only happen in the linear probing, and that is resolved in the quadratic probing. I will show you that how you resolve in the quadratic probing. So next is that secondary clustering, and that's nothing but the quadratic probing. I will explain that how you resolve the primary clustering probing, because here in the secondary clustering what you are doing the square. The name is saying that quadratic probing is that here you are not checking immediate next, here you are checking the square next. So whatever the next immediate square index is free, there you store, and because of that reason you save some more time. You save somewhat. I'm not saying that 100%, but you are saving at least 50-60% of the time you are saving that. So here you are simply going with square value. In linear what you are doing, checking that immediate next, linearly you are checking that, right? But in quadratic you are checking that square. So because of that reason the primary clustering problem resolved in the quadratic problem. right? So here also same thing, saying that if two keys contain same starting address, they both will follow the same path unnecessary in quadratic manner also. So why the second clustering is saying that there is the same problem here also, but previously but was the primary clustering. Here you will see that the secondary clustering problem. In secondary clustering problem is also what happened, that two element also get the same path. Either you have done a square also, but you only resolve the primary clustering problem but not to secondary clustering problem. I will show you that also why I am saying that secondary clustering problem, and everything I will going to explain here also with the proper scenario, so you can easily understand why I am saying that. Because you thought that the both is following same index, same thing, that you are saying that, then why was the difference between primary and clustering? So there is a one difference, is that the primary clustering you are checking each and every index, but in the secondary clustering you are checking that squared one, and that too getting the same sequence, same that's called probe sequence, the same probe sequence. And probe means searching, then you can tell the search sequence. So I'll show you the scenarios better for better understanding here. So if you are see that in primary clustering, what you have, see that you are seeing that the some slot is getting the more probability, some slot is getting more probability, and because of that reason that the problem arises in the linear probing. But here in that secondary clustering you will see that the path, if you see the path, you always see that the path is getting the same path. If it is two element get the starting index same, it will always get the same probe sequence, it will always get same probe sequence. So suppose here I am going to insert 50 in my table, and if I am going to store 60 in my table, using the what, using the quadratic probing, then what happened here, I have seen that here I have calculated the index. So 50 is first index, what it is getting 1, 50 second index, what it is getting, that 4. And here also the look at the table, look at the second table. If you are going to insert 60, starting index is, you are getting starting index is 0, then what is the first, 1 4 9. If suppose that the fourth was not free now, then again you will get the index here also, here 9. And because of that reason, if collision occur and if two element is starting index is same, you will get the same probe sequence, that is 149. Here also you will get that 149, the next you will get that 16, next you will get that 25, like that you will get the probe sequence, same probe sequence. And this was the problem with the quadratic. Means in quadratic, if two element will get same starting index, their probe sequence is same, and because of that reason their time complexity, the average case time complexity and worst case time complexity is increased. And that is the problem of the quadratic probing. Quadratic is resolve the primary is probing problem, that is the primary clustering. Linear probing problem is the primary clustering, that is resolved. But the another problem came in the quadratic probing is that if they squared na, they will get that same probe sequence 1 4 9. This seemed like here 149. So this probe sequence they got, and because of that this is called the, this is the problem with the quadratic problem. So now we'll see that how we will resolve both. Primary is clustering resolved by quadratic, secondary I'll explain in the double hashing. Double hashing resolve both clustering, either the primary or either the secondary, that is all, that is resolved in the double hashing. So I'll explain here the double hashing advantage. You can say that advantage means yes, it's resolving the both problem, primary as well as secondary clustering. So here there is no problem. So here 99% secondary clustering problem also eliminated. Here saying that 99%, but still one more percent is there. Why? So even the collision resolution technique, what it is saying that it's not removing the complete 100% collision. It's trying to reduce the collision. So don't ever say that collision resolution technique helping you to reduce 100%. No, it's not. It's just 99% only reducing. It's not completely removing it. So here in double hashing, what it is saying, the same situation, if two key element starting index is same, then it follow a different path. Region is what? Region is what? Here the double hashing. So hash is different. Previously what you are doing in the linear probing and quadratic, there is a one I value you are using, and in linear I is increment by 1 and in quadratic I is increment by 2. I is increment by square, right? But single hash function, you are working on the single hash function, right? Because of that reason you are getting the clustering problem. But here is the situation that in double hashing you are using the two hash function, and that will give you completely different path. If it is two hash function you will use, you will get completely different path, means different probe sequence. And because of that reason you are resolving here both clustering, primary clustering as well as the secondary clustering. So if you observe here the table, you can see that this is the one cluster, this is another cluster, and this is another cluster, and this is another cluster. And here there is no primary linear probing. I'm using the double hashing, so I'm using the another hash function. So here I have taken one hash function, another hash function. So if you calculate, suppose here I'm going to insert 7 and 12. So look at that, while inserting the 7, first time if you calculate the index using the first hash function, you will get the index value is 7. Look at that, 7 is free? No, not free. Then what will you do? 7 is not free. Then what will you do? Check that what? They check that the next index. Calculate the next index. For the next index, how will you calculate? First index plus second index of the using the index you calculated using the first index first hash function plus plus the what is the value of the second index. Calculate the put the value of key in the second index, and whatever the value you are getting that. So 7 is you are getting with the first hash function, 2 you are getting the getting from the second hash function into I, and I is start from 0 to m minus 1. So here I am taking 1. Why so? Because 0 is not affecting anything, so I have taken 1. Then modulus tables I did, I get that 9th. My second index I'll get that 9th, and I'll check that is 9th is free. No, 9th is not free. Then I'll do with the next. 9th was also not free. Then again collision occur, and again collision occur. So what happened? I'll check that next. I'll increment the I value. So I will get that 7. With this 7 is nothing but using first hash function I calculated. Then I'll get 7. 2 is using second hash function I get the 2 value. And into I is previously 1 I have taken. Now incremented I with 2. So now it is 7 plus 2 into 2, it's 4, means total is 7, 4, 11 modulus 10 you do, you will get that 1. Check that 1 is free, that 1 is also not free, right? Now increment the I value is 3, then calculate the value, check that what index you are getting. Like that you follow the process, and then what happen if you observe it now while calculating, you will see that this path is not matching. So this is the 7th. I have added for the 7th. Similar like that, if I am going to store 12 and I'll do calculate that for the 12. For the 12 also the starting index you will get the 7. Right? And using the second hash function you will calculate that, you will again get the 7 and then put the I value, and you calculate, you will get the index 4. So if you observe here the both table and the both key 7 and 12, starting index was what? Starting index was 7, right? And if you calculate using the second hash function, you will see the path, both path is completely different, it's not matching. And because of that reason the double hashing is solving the problem of linear probing as well as quadratic probing. It's removing the primary clustering problem as well as the secondary clustering problem. And that's the reason their best case and average case time complexity is order of 1. But still one more thing is that, one more problem with the double hashing is that the worst case time complexity is still order of 1, order of n. Double hashing is also having one problem, and that is their worst case time complexity is also order of n. And this is the disadvantage of the double hashing, and that is only resolved by the perfect hashing. So the double hashing problem was that its worst case time complexity is still order of n only. So that is going to resolve by the perfect hashing. So that's all about this video. I have explained about that the problem of the linear probing and the quadratic probing, and how to resolve the problem of the linear probing problem and quadratic probing problem, and what is the problem of the double hashing that is going to overcome by the perfect hashing. That's all about this video. Thank you for watching my video.